So we'll start with like so we really happy to have here Tejal and Kevin. The way I introduced you guys last week, I said, you know, I'm not such like an OpenAI fanboy that I think like everything we do is the best, but I think we do have the best frontier evaluation team anywhere. So so we really will be happy to hear from you. And the way we decided we'll do it is I'll give like a 20-minute kind of introduction based also on the blog post that I think some of you have read about how AI will impact the economy. And then we'll hand it off to Tejal and Kevin. And at some point that feels natural, let's do a break, and then we'll also have the student experiment that we. Okay. And I think this meeting is being recorded, and we can decide later what to do about it. Yes. Okay. So I want to give kind of like a little bit of what I think AI will look like in the future. Or maybe can even make it full screen if I figure out how to do it. Is there sure there is some way, but okay. You guys can see the slides, right? Yeah. Okay. And yeah, so the way I view it is, you know, AI is getting better and cheaper, and we are so those are the graphs that we've seen. Another graph that I kind of really like from the Smither paper is that a priori you might think that you know, it will still be kind of incomparable, and the tasks that are really, really easy for humans, there is still some of them would be really difficult for AIs. But we kind of don't really see it. Like we see that eventually the tasks that are easy for AI, easy for humans become basically 100% solved. But basically is with a huge caveat. It's not in the adversarial setting. So in a sense, it's not worst case. We can always find inputs right now, at least. We haven't solved adversarial robustness. We can always find inputs for easy tasks that our models cannot solve, but they do get basically a very, very high reliability on things that are easy. So these two things together bring me to kind of my mental model, and Kevin and Tejal or anyone else, if you have disagreement with this mental model, feel free to either say it now or say in your talk. So my mental model is that basically the easiest way to think of AI is like we are basically going to be injecting an exponentially growing number of virtual workers into the economy. And every year, there are not just going to be a larger number of them, but also they will be more capable and more general. And initially, it might not be robotics, but robotics will catch up to later on. So it's nothing is necessarily out of bounds. So the way I view it is, you know, there is going to be some kind of a chart like that. The base and the base of the exponent is yet to be determined, and where the number of workers basically grows exponentially every year, and their generality and quality also grows at a significant rate. And I'm imagining diffusion will be more bumpy. There might be some various reasons why in some parts diffusion is slow, etc. But if they become kind of bigger and stronger, if diffusion is slow in the beginning, eventually it will catch up. So my take is that in the limit, within about, like, let's say 20 years, maybe less, we are going to effectively tenfold increase in the global workforce. And just to kind of get a perspective, yeah, like, so in the blog, I try to kind of do some math and compare it with some economic models. And just as a sense, basically, this is under the assumption that the kind of exponential growth that we're seeing will mean that we're going to see an automation rate that is kind of unprecedented compared to what we have seen. So instead of seeing automation rates that in the past have been kind of on a single-digit % and then going down with time, so leading to kind of more like linear growth in automation and not rather than exponential, we're going to see double-digit % of automation. And so let's say we are automating, every year we are automating, say, 10% of the tasks that we didn't automate before. And with this kind of growth, it doesn't even matter like how much the cost decrease, we are going to get like a lot of, we're going to get explosive growth, and explosive not in the sense of the singularity that everyone dies or we immediately go to heaven, but more like basically industrial evolution level. And if you think again, like what does it mean to 10 times the workforce? So the global population, up until now, the workforce has been humans. So I think the way to think about it as the last time, since the global population has grown by a factor of 10, we have to go back to 1750. And basically the industrial revolution enabled us to grow the workforce, and the scientific revolution enabled us to grow the population while feeding everyone, in fact, feeding better than ever before. So the global GDP has grown exploded since basically the 1700s. And if you say, okay, these are just economics, it doesn't matter, like also other statistics like life expectancy and child mortality have all greatly improved since then. And you might say, well, maybe just the rich states and rich people inside the US and poor people are still in bad shape. But no, I mean, this is, first of all, these are global numbers. So this is average over all the 8 billion people on Earth. And even if you compare, there is definitely inequality. If you compare, say, here, the United States versus the world versus Sub-Saharan Africa, there are big differences, but the trend is the same. It's going up. And the trend in life expectancy and child mortality is the same. It's going down, and down by a lot. In particular, if you look at, life expectancy in Africa today, it's beyond it's worse than the global average, but it's worse in the sense that it's, I guess, taking a look at these graphs, I don't know, it's like basically maybe 1980s level of the world, or something like 1980s level of the world. So it's not like it's 1700s or something like that. And yeah, and again, like for a sense of proportion, like even the absolute, in a very real sense, even the richest people in the past have lived worse lives than the average. I mean, obviously, you can always find a person living today that has like really miserable life, and a person living in the past that had like only health and great health and longevity in the past. But generally, even if you take like the typical American or the poverty line, in many ways, their life, not in all ways, but in some ways that matter the most, their lives is better now than the lives of royals in pre-industrial times. So just got one example, like the Queen of England. She's pretty typical, I think, example, or maybe more extreme than others, but she had 7 children. I don't know how many miscarriages, etc., but she had 7 live children. Out of them, 5 died before adulthood. I don't remember the precise numbers, maybe 3 in infancy or toddlerhood, and the 2 in the teens, or like around that. And she died on her 37th birthday from the last birth. There was an infection, and the baby itself died also basically within a few days. So that was life, even for the royals, even for the Queen of England. And so the bottom line is that if we are going to increase the, if AI is even indeed going to increase the global workforce by a factor of 10, I think it's going to be a radical change. And overall, it's probably going to be a radical change for the better. But there are, like, this is an AI safety course, and we are worried about the way it could go wrong. So, like, in just a few minutes, let me say a bit of my personal stance. And again, like, feel free, people, to push back. Maybe if we'll have time at the end, maybe we'll do some more Q&A with me and Tejal and Kevin, and you can ask more. So I personally less worried about, like, the classic doom scenario of the AI taking over and just killing everyone. And I wrote like a semi-review of this book, and you can read it, and I'm not going to go into all of it, but generally I say it's true that we don't have full control and understanding of it, but I think it's not like zero control and understanding either. So the Yudkowsky type of point of view is these are huge matrices. We have no idea. They could basically be plotting to kill us at any given moment, and we'll have no clue, and we have zero way to influence them. They will develop their own weird objectives and pursue them relentlessly. I don't think this will be the case. I don't think we can fully control and fully understand. There's a big spectrum between complete control and understanding and nothing at all. And I think we are somewhere in the middle. And we are definitely not as close to full control and understanding as I would be personally comfortable with. And that kind of brings us to this other point. So I'm kind of mostly worried about that we are going to have, maybe unless I'm wrong and AI will just fizzle and hit a wall, like has been predicted for been predicted very often and many walls ago. So if AI is going to continue on anything like its current pace, we are going to have like a huge magnitude of change in a very short time. And we're going to squeeze maybe, 200 years of progress, 100 years of progress, depending on how you count, to 10 or 20 years. It's going to be a lot. And I don't think society is ready. I don't think our government is ready. I don't think international relations is ready for something like that. And I think the lack of technical safety, the fact that we don't completely control these AIs, the fact that we don't yet have ways to prevent abuse, to make them robust and make them truthful and all of those things, they can be just make these things worse and create a lot of unknowns. So I don't know exactly what could happen wrong, but I think this combination of factors of rapid change in a short period of time and with not a long significant level of control is a problem. And one slide I sometimes like to say is, with aviation safety, we have managed to really bring down the number of accidents, but it took us 50 years. And in those 50 years, the product basically stayed the same. Like if you look at a jet plane from the 70s and a jet plane from now, these days it's more fuel efficient. There are some advances, but it's very much like basically the advances that you had between, I don't know, GPT-4 and 4.1, or maybe 4.0 and 4.1 or something like that. It's like if you compare what is happening in a decade in AI, it's more like not two types of plane, but more like you're going from a bicycle to a plane. So we are trying to make this safer while it keeps changing under us. So it's a problem. Another thing I'm personally worried about is AI and political power. So I think AI potentially can empower individuals, but it can also disempower them. And I think AI has the ability potentially to amplify the impact of one person. So one person could do much more. Maybe it can increase transparency of government. You cannot bury like a small person or nonprofit by a mountain of paperwork. and maybe you could even demand that AI will go through government communication and ensure that everything happens basically as it should happen. I think actually in the long run, the AI might favor the defender in battling disinformation in the same way that AI in the long run ended up, I think, helping more the defender for spam email. But on the other hand, like you can have the flip side of that. AI can enable government surveillance at a level that we've never seen before. Even highly totalitarian governments were bottlenecked by the fact that they couldn't really afford one spy for every citizen. Maybe now you could afford 10 spies for every citizen. And AI is going to be intimately involved in all of our communication. So unless we change our laws or make sure that these communication is protected, you basically could have the case that all of these very, very personal communication between you and your AI is going to be able to subpoena, surveilled, etc. And if the government has obedient AI workers, then that means none of them will ever refuse like an order that violates the Constitution, or no one of them will ever whistleblow. And that also could be a recipe for totalitarian government. So I think it's basically, I don't remember if I have like one more thing here or not. Yes. So the other thing is that basically, if potentially it could be the case that in private citizens will have less leverage in terms of withholding their labor in AI world. It's not. I don't think that's the only leverage that people have. At least not, definitely not in a democratic society. So but it's one more thing. And I think whether we go down the green path or the red path is not so much about the technology. Although I hope that people that come out of this course can have influence, maybe more than the average person on that, but a lot of the policy decisions that we'll make, but some of it might also end up what the technology enables or not enable, and what avenues companies pursue or decline to pursue. And there are other issues that people mention with AI, and maybe there are more issues than I mentioned. So basically, environmental impact is real, but it's often grossly exaggerated. If you read something about the environment in New Yorker or New York Times, if you're lucky, it will only be exaggerated by 1 order of magnitude. If you're less lucky, it will be 3 orders of magnitude. And I think job displacement is an issue, but economic growth will help a lot. A lot of the kind of the debates in the US, for example, do you have universal healthcare insurance? What do you do about Medicaid, Medicare? What do you do? Social Security, balance the budgets versus tax cuts. All of these things, if you even had like 4% growth instead of 2% growth, these issues would disappear. If you had 10% growth, then it's kind of completely different story. And while I think many of the people, probably most of you in your future, and I think that's also true for Tejal and Kevin, like I actually enjoy my work and it gives me meaning to some extent. I think many people, most people just work to get a paycheck, and actually would be fine not working if they still get the paycheck. And I think generally, like in economic inequality, I think as long as we don't fall into authoritarian government, as long as it doesn't become like a kleptocracy or whatever, then there's going to be so much prosperity that we will lift all boats. And yeah, I believe, yeah, even if I trust humans, we will find meaning in our life, even if there are no more accountants and no more. So I think a lot of these accountants will take up painting, and maybe they'll turn out to be very good at it. And with that, basically, let me on to Kevin and Tejal, but I'll do one short break. I usually, or like intermission. So I usually, in my classes, I often at the end of the class, I do some kind of a video clip with excerpts from plots, and then And I thought I'll do something. I'll do something like that here, but instead of like this is AI, I asked Codex to do it. So I basically gave Codex a bunch of. I basically gave Codex all the slides of the PowerPoint, and I said a music MP3 when the Earth dies, which I thought was appropriate, and I said, well, you know. And go look for, and eventually I also got some from ChatGPT, go look for memes, etc., and make a video clip out of it. And Tejal, maybe that will be like, Codex is still not very good at it, so maybe that's the next evaluation. But let's see if it works.
Soft drinks. Soft drinks are awesome.
Overview. So we want to tell you about a couple things today. First, we want to tell you about an eval that we worked on called GDPval, where the goal was to measure real-world tests. And then we'll talk a bit about how we're thinking about automating AI research and measuring the pace of that, and then have some time to talk through the safety and preparedness implications of this fast progress, and then hopefully have a very fruitful discussion at the end. I also know there's a student presentation that will come, so we'll make sure there's time for that. Our presentation will be short. So maybe to start with talking about GDPval. So GDPval is something you might have seen on Twitter. There's been a lot of press about it, where we were basically trying to build a benchmark to measure how well our models can complete real-world work. And it went pretty viral. It was like #1 on Hugging Face, basically within a couple days. And the reason it went viral is that historically our ability to measure AI on real-world work was very limited. So we would have these tests like MMLU or GPQA, where we measured how the models could answer academic-style questions. And GDPval was one of the first ways that we could measure if models could actually do real work in the real world. And I'm really excited to tell you guys a bit about it. Maybe Kevin, if you go to the next slide. Um, More people are talking about it, their think pieces. You can go to the next slide. So yeah, our goal for GDPval was this was very much a first step towards measuring how AI models can perform real world knowledge work. And when I say real world knowledge work, I mean the kind of work that can be performed on a computer. Think about things like accounting or law or finance. And really until this moment, we didn't have a systematic way to measure how models would do over time or create forecasts. It was very much us relying on customer opinions or sort of like articles that people would write. But we're really interested in measuring how models can do even as we train them and then sharing that information with the real world. And there's a lot of limitations here. But the reason that we care about doing evaluation on this sort of task is because understanding the impact of AI on labor is very important. As Boaz mentioned, there's like a lot of speculation about what might happen. There's also a lot of, very sensational articles on like AI might take away all jobs. And it's really important to have a science and empirical grounding to this. But what people can look at right now is stuff like usage or production data or actual impact on GDP. But the problem with a foundational technology like AI or AGI might be is that these are very much lagging indicators of when the capability exists. So if you look at major technological shifts over time, things like the internet or railroads or airplanes, it often took years or even decades between a capability existing and widespread use, from airplanes existing to everyone using airplanes to be able to work anywhere in the world and visit their customers and their clients. That took a really long time. Another example is self-driving cars. Waymos work pretty well, but it takes some time and cultural understanding for someone to be willing to get in a Waymo and realize that it works. And so we similarly want to proactively forecast what these models can do because we expect it'll take some time to adjust regulation, have cultural shifts. People just get used to using these models in their actual everyday work. But that doesn't deny the fact that the model might already be capable of some of these things, and we want to forecast them. So that's why we wanted to measure it. The other reason that OpenAI, is interested in this is that part of OpenAI's mission is, to help ensure that AGI is beneficial to the world. And we think AGI is inherently going to involve completing economically valuable tasks. And so we want to sort of measure those and have a good science of them. So let me start by showing you some examples of the types of tasks in GDPval. So this comes from our paper, which you can find online. But on the right-hand side, you have an example of an actual deliverable that someone actually did at work in their real job. This is work that people either already own themselves or they got permission to include in the eval set, and they would like scrub it to make sure there's no like PII or anything like personally identifiable information or anything like that. But it's very, very diverse. So for example, in the top left, you have a manufacturing engineer that's designing a cable reel stand. And you'll notice this is like a very 3D multimodal task. It took a long time for this person to complete the task. And then they give the context or files they might have had access to when they had to actually make this cable reel stand. And the goal is to see if the model can do the same thing. Can it also complete this piece of work a person had to do? In the middle top, you have a competitor landscape, which is like if any of you have done a banking internship, like a classic thing that you have to do when you're diligencing a company that you might acquire or help someone sell, is you try to understand what are the other competitors out there and create this very detailed landscape of all the other comparable valuations. And so this is another type of task. And then I've given a bunch more examples here, like, real estate agents, customer service emails, creating video and text reports, making a consultation report for a nursing position, analyzing a bunch of Excel data, making itineraries as a concierge, working in Parks and Rec, and making layouts of where different vendors might sit. And all of these are intended, there's a range of time horizons on these. Some of them are, multi-hour long tasks. Sometimes they're multi-day. Some of them are even multi-week. We had someone submit, like, they wrote like a whole book and they were like, let's test how long it might take the models to be good at this type of task. And this is like real work. I mean, it's not the same as automating an entire job. It's a very well specified task where you have a specific output and it's restricted to stuff only on a computer. It doesn't include manual work, but it is a lot more realistic than the types of tests that we might have been giving our models earlier. And seeing how well models can perform is pretty interesting to track. So maybe just on the next slide, how we picked the tasks in this initial set We just wanted to start with the sectors that contribute more than 5% to US GDP, just so that we have a place to start. And then we picked the highest earning occupations in those sectors that are primarily digital work. So we didn't really focus on tasks where it's mostly manual labor. These are very much knowledge work tasks. And then that's how we seeded the first set of tasks in the first version of GDPval. It's called GDPval because it's an evaluation of GDP relevant tasks. And here's some examples of the occupations in there. They're really diverse, like everything from editors to registered nurses to real estate brokers to pharmacists. And recruiting all these people took a long time. We really cared about getting the best of the best, and we wanted to get a very diverse representation of jobs. So the reason we cared about getting the best of the best is we're interested in whether models can really, really excel in these tasks. So we had folks that had, a ton of work experience on average. They had to have a top resume. We had a bunch of background checks. Basically, we wanted to make sure that the human comparison was a really strong human. And if a model can outperform a human on that task, it actually means something. Like it means that the model is better than a really talented individual with a lot of experience, history of promotion in that same in doing that same piece of work. And so this is just some examples of what the experts had to pass to be able to be the human that we compared against and help make the tasks. So one of the things that you might care about before I talk through results is, are these tasks actually representative? Was there good quality control? And so this is just, we had a ton of QC of both models and humans, making sure that the tasks that we included were very representative, that they were actually solvable, like the person didn't actually forget to include like the reference files they might need to complete this piece of work, and just a lot of review to make it as high quality as we could. And maybe on the next slide. So now I'll talk about grading. How did we actually grade if, you have a task with a prompt and you want to see if the model is better than the human? How do we actually grade which is better? So the first thing that we did is just have experts that are not the same people that made the task, a separate set of experts, pretend that they're the manager and say like, hey, if two reports gave you these two pieces of work, which one would you prefer to use? And so that's option one. Maybe Kevin, if you go to the next slide. Um, yeah, they had to have a lot of experience in their field. They had to pass a screening test. And then on the next slide, we show you what this actually looks like. So for every one of these comparisons, and we had to do for each, question that we asked, we had at least three experts look at these, look through that specific question, and they looked at least three samples from the model. And each time they just did sort of a pairwise comparison of which is better, the human goal deliverable that the human actually did on their job, or, what the model said, for example, GPT-5. And then they would think about both objective criteria, like, which is more correct, and also subjective stuff, like which is formatted better, which is easier for me to read, which is more understandable. And that helps us roll it into an overall win rate. So if you go to the next slide, here's one of the headline results that we published. And so I want to start with just talking about the y-axis, which is the win rate versus an industry professional. So that means what percent of the time did the experts think the model's output was better than what the expert actually did in their real jobs? And 50% would mean that roughly half the time you prefer the model and half the time you prefer the expert. And
So
I think,
Tejal, I
yeah.
don't know if you can hear. I'm curious. You said you had multiple samples from the model, but the win rate is still like for one door. It's not like best of three or something.
No, it's not best up, it's averaged.
Yes.
Yeah. So let's start on the leftmost side. So Kevin and I both helped work on GPT-4o and Boaz too, actually, I think. I think you were there at the time.
I don't know, I was there, but I didn't work that much.
Okay, well, at the time, we were very, very excited about GPT-4o because we were like, this is like the best model we've ever put out. It's omnimodal, it can like handle image. And, if you actually use GPT-4o at the time, it's like pretty bad compared to an expert. Like you would basically only prefer a model output like roughly 10 or so percent of the time. Maybe it's like tied a little bit more. Wins and ties means when the expert can't really tell the difference. So they say that it's a tie. But if you look to O3 or GPT-5, you're seeing that we're already starting to get much closer to parity with an industry expert. And actually, if we plotted ChatGPT agent on here, it would also fall on this line. And what was really exciting to us was, first of all, the models in absolute terms are getting much closer to industry expert than we would expect. I mean, again, this is on very well specified tasks, but they're pretty realistic. and the trend looks roughly linear-ish. And so the natural question is, if you just extend this line, when might we be at parity with these experts? And that was pretty interesting. And if you go to the next slide, we also plotted other models and sorry. I'm so sad I'm sick because I'm so excited about this stuff. Claude actually, which we wanted to be super objective about our results, was getting really close to parity with an expert already. And again, this is not every task that you would possibly do on a job, but it's getting pretty close to parity. Okay, one other thing that we thought was pretty interesting is that you might wonder how someone could incorporate using a model in their workflow. And so you could imagine a setup where a human expert, like say you're an accountant, you sample a model to be able to complete a task. And then if the model does a good job, you'll use that completion. But if not, you'll just sort of do the task yourself. And a question we had was if humans sampled from models first before they tried doing the task themselves, like would they save time or money? And so we actually simulated this where we set this up with a bunch of our models. And it turns out that for every model since GPT-4, if you sample from the model before you do it yourself, it actually saves you time and money. If you look at GPT-5, it's like 1.4x or 1.6x faster and cheaper. This is crazy. I wish I could show you how exciting it is. And it's only getting better. We have a bunch more cuts of this in the paper that we don't need to get into here, but one thing that we thought was interesting is the OpenAI models are actually quite good at pure text compared to Claude, but Claude was better on all of the multimodal files. So internally at OpenAI, that was a pretty interesting point of, hey, we're like not very good at file extensions right now. We could fix that. We also have some, we can go through these pretty fast. If you increase the reasoning effort on solving these problems, you tend to do better. This slide is pretty interesting. Okay. So I said before that the models are getting close to parity with experts on some of these well-specified tasks. But just because a model can, it's very interesting to know how the failures that the models have compare in magnitude, right? Like the human might prefer a model completion, but it might be that the failure was so bad it'd be catastrophic. So for example, you would not want a customer service agent that like called the customer a moron, or like if you were in a medical case, if the failure from the model was the model like killed someone, that'd be like very, very bad, right? And so for me to trust putting a model in the loop first, the risk of catastrophic harm has to be pretty low. And so we did a follow-up where we had human experts rate the times that the model was not picked. So these are just looking at the subset of samples where GPT-5 was chosen as like worse than the human. And the breakdown is pretty interesting. So about 23% of the time, the humans thought that the model was actually better. And that aligns with our inner annotator agreement, which is that the experts didn't always agree on whether the model was better or not. And so there's some subjectivity here. Roughly 50% of the time, folks thought the model was acceptable, but still worse than the human. 27% of the time, it was seen as like just totally subpar, and 3% would be catastrophic. And from our perspective, that would be so bad that like you probably wouldn't be able to use the model in production without a human supervising because the catastrophic outcomes are like quite bad. But if we can get this catastrophic rate down, you might think the models will be more usable in the future. So that's a quick set of detailed results. Maybe Kevin, you want to talk about some of these? Because I feel bad that I'm losing my voice and like the results are actually kind of cool.
Yeah, I can talk about this stuff. I think it's like kind of interesting like what models get wrong. Like a lot of them are just like basic instruction following problems. Like it'll be like, oh, you're asked to like put a deliverable or like give a certain file type. And like for a human, like, you know, emitting a PDF or a slide deck is not that much harder than just like writing something in like a file or something. It might even be more natural if you use like PowerPoint a lot. But for models, it's kind of hard. There's a lot of like really interesting formatting problems, which I think will be described later. But yeah, also it's like, you know, models with the tool limitations that they have, they might struggle to parse, especially like multimodal data or very large or different file formats that they haven't seen a lot in a lot of their usage. Yeah, and so like we can get into some of the formatting elements, and yeah, and then I think also another one is accuracy, where just like, I'm sure you guys have experienced this, like sometimes like GPT-5 thinking even will just still like give you a number, and then like you will check and be like, oh, this is like kind of wrong, or there were like 3 sources that were like leading to this thing, and like 2 of them like said this, 1 of them did not. And that is just like a major error in failures. Yeah. Also, Tejal, let me know whenever you want to jump back in also, because I'll just try to present these reasonably in that case.
Going, because like the content is so good.
Okay. I'll keep going. Okay. Yeah, so I mean, you can just kind of see like it's like interesting in the sense that like models really just struggle with like the basic formatting thing, but often like the data itself is like much more reasonable or something, like the analysis done is much more reasonable. So just like a random slide, and it's just like not good. Like if you just like, I'm pretty sure like anyone would probably be able to make a better slide than this in terms of the actual formatting on the presentation. You also ask ChatGPT agent, like honestly, like sometimes it just does this kind of stuff too. So you can just replicate this publicly. There's like, yeah, like lack of like visual elements, like goes off the page, like there's like very simple reasons why the deliverable will be considered subpar. Also, another interesting thing is like the model, I mean, the model often like might not see the exact format in which the final deliverable will be rendered. Like for example, this is the weird Unicode thing where like sometimes it'll use like weird characters that like in particular fonts just like don't show up correctly. So like this is like another problem where like a lot of the deliverables that are actually rendered have like these weird like subscripts and like dashes that are like not actually like they don't actually render properly.
Yeah, but if we have a font that doesn't have M dashes.
Yeah. And it's like very hard for the model to tell this basically as well. Like you kind of need like closed loop image perception or something if you wanted to see this. Let's see, what's this? Model get better over time. Interesting. Yeah, I think here it's like, okay, so here we can kind of click through. Okay, yeah. So here, I think this is an example where like you can kind of see the evolution of the output created by the model. You can kind of see like 4.0 just has like a bunch of these charts, and then like O3 changes. It has some words. It has like a summary. Like this is pretty good. It has like a lot of like detail about the summary as well. And then like GPT-5 like actually it's kind of like a themed presentation where they have like colors and like it's like actually like makes it like much more readable or something. And so this is like an example as well. Yeah, I'm not familiar actually with the like raw data, but like you can see that the model in terms of actual formatting and presentation is like still actually getting better as well. Let's see. Another one is like this one, which is like you were the safety coordinator and you must create a monthly safety checklist that like establishes a secured environment at like a retail store of like foods and groceries retailer. And then like 4.0 just like writes some stuff in like basically a Google Doc level, which is just like a few like reasonable bullet points. O3 has like a table, like you can have comments, like you can like actually, you know, imagine printing this out and using it in reality. And then GPT-5 has like a crazy detailed, like there's like a nice table, like it has like a summary, so like different sections, like coloring, like actually like makes it like somewhat better or something. Yeah. Okay, here's an example of like, this is like a model and a human response. And I'm curious, like, which one do you guys think is like better or something as well?
But you should make them raise their hand.
Okay, raise your hand if you think the left one is better. And raise your hand if you think the right one was better. You guys aren't allowed to say tie in this case. That's way worse. Okay, so which one is the real one?
Wait, we should also have them guess which is model and which is human.
Oh, okay, yeah. Which one is, sorry, raise your hand if you think the left one is the models. And then raise your hand if you think the right one is the models. This feels kind of even. Maybe it's like slight left. I'm not sure. Yeah. So which one is it? Which one is it?
Guess I don't remember. Which is very it's illustrative of like they're kind of starting to look the same. I think the left one might be the model, which is the one you guys thought was better.
I mean, the last one is prepared by nurse
Prepared by nurse practitioner doesn't give it away because we had them remove their names.
Okay, so maybe they changed their name to the profession.
Let's see. Okay, yeah. Another thing which I'll discuss is like the kind of like prompt tuning that we did to like see if we can just fix some of these like really obvious failures. I mean, you can kind of tell like a lot of these are not really like intelligence problems. Like they're just like the model like didn't do the right thing or like just like didn't format PDFs very well or something. And so we basically created an extremely detailed prompt that just listed every possible problem. And then also can use best of 4 with GP5 trying to pick which one is actually better. And you can see that this actually does like materially improve performance, which is I think it kind of symbolizes like there is so much low-hanging fruit here, like in the sense that like models are extremely capable, but it is like if I am like, you know, accountant or like someone working like job branch, like creating like a PDF, there are just these like small, tiny nitpicks, which can be fixed very easily, but are right now just like preventing me basically from doing the entire thing with the model. And so like, this obviously isn't a huge increase, but I think it's kind of a sign that like just a very simple intervention can actually also improve performance. You can kind of see here, like, you know, there used to be these artifacts that became 0, like these like overlaps became much smaller, especially because you can like just ask the model to like, please look at it and make sure it's like actually correct. Yeah, and then like, yeah, there's like a lot of it actually will render the image, so it'll look at it. And then like, also there is a small amount that's like corrupted files for some reason, like during the rollout, the model produced like a corrupted file as well. Yeah. Yeah, this data set also, there's a set that is publicly available. Would be very curious to have people try it out, try different models on it, like try different strategies and like see, just like also just like take a look at what the data is like. I think it's like very interesting to just like look at the first 10 prompts and be like, actually, like what information are we telling the model when we're evaluating on these cases? And in what ways do you think it is realistic and not realistic? In particular, a lot of these prompts are extremely detailed and like give a lot of context because the model has no context on the job. It's like if you're just told on Slack, like you're not going to get like a 13 paragraph like explanation of your job, but like the model will in this case because it doesn't know. Yeah, yeah, and then we also have this website evals.openai.com, which lists all of the other evals that we've made. So like we made a bunch of other evals too, like Paperbench, was like reproducing ML papers, which we'll talk about later, and yeah, a bunch of others. Yeah, and yeah, that's basically it. I think there's like still one thing to call out is like obviously there are a ton of limitations with this work. One is of course that like it is a small fraction of economically valuable work, primarily because it's digital only. There's only a limited set of occupations. The deliverables also are very self-contained and one shot. And it doesn't measure. For example, like if you've worked at a job for 2 years, someone can tell you like one sentence and you know how to expand that into an entire like task that's very well specified that you know how to do. This does not measure that. It's like a very, like the deliverable is literally just like a single piece of text, which like anyone should be able to use to create the actual output. And so we would claim that this does not measure performance on entire jobs, only these like well-specified subsets that can be well-specified, but also is hopefully a good step toward understanding like in this area, like how good are models and like what are the remaining limitations as well. Yeah, that's basically it. Anything else?
Before we go to the next section, should we ask people like, are you scared?
How many people feel scared? I guess, I don't know, I would say, what do you think, like 40%, 30% scared? Or,
That's not that scared.
Why are you guys scared?
I'm scared, like.
I mean, maybe also like people have like now questions about GDPval before we move to other stuff, raise your hand. Yes.
Thank you for the interesting presentation. I'm curious if you can share how you found and convinced these experts to contribute to this study, especially given this general sense that you're figuring out whether or not their job can be taken over.
Yeah, I mean, I think one, we compensate people pretty well. And you know, there's markets can incentivize behavior. I think too though, our motivation was more to do this for science and like to share this as research. And I think people are pretty interested in knowing like, can models do these tasks? Like this is just valuable information to have. And so it was actually funny when the paper came out, the experts were like in the Slack channel being like, this is such amazing work. We're like so excited to have contributed to it. So I think the specific style of work we were doing was relatively non-controversial, but I think you can think of the extension question of how excited would people be to actually work on making the models good at their job, which I think might be a different question. Wait, can we ask the people who were scared why they're scared?
Are you scared?
I said scared is not the right word, but like apprehensive, maybe. I don't know. Do you have follow-up questions?
Or like, are you well, one thing I was thinking about is I was like, like, I don't know if this class has a bunch of seniors or juniors, but it's like a lot of the work we're measuring is entry level, like what you do your first or second year out of college in many of these jobs. I mean, you guys are Harvard students, so you're probably fine, but I'm just like curious if people are stressed about this sort of thing.
Well, since I have the microphone, I guess I can talk about my experience, which is that I just came from industry. So I was working like an entry-level job in finance previously. And I think one reason that I wanted to come back to school was because I kind of felt that, this would catch up to I kind of wanted to, be at the forefront of this type of stuff. So I didn't want to just like sit and then have, GDPval evaluate my job easily. So yeah, but that's why I came back.
Anyone else has like comments on the scariness or you want to say something? Yes,
Kind of. I think I have some degree of skepticism over what in Boaz's earlier presentation talking about the rising tide lifting all boats. It's just my like very subjective perception that a lot of people like we're kind of in a niche community, and a lot of people out there have a lot of hesitation towards AI and just kind of fear around it. And I think in this like rapidly changing world, you're kind of hoping that, the people who got their current work might get displaced, that they're going to find opportunities to upskill or to change their skills or adapt. But I think there's also this, I'm worried about that fear kind of like limiting a lot of people in a certain way. And I don't know structurally if we're like equipped to handle that transition.
Yeah, no, Tejal, feel free to comment or
I thought that was a very reasonable point.
yes. Yeah, I mean, I think that just to be honest, I just think that if AI really does displace a huge number of workers, right now AI's impact on the industry on employment is very limited and mostly like in some particular. But if it becomes very, very significant, then because AI also becomes like every job it can replace now, it can next year do better and cheaper. So it's hard for me to see how it can do that without creating a lot of economic growth. And then even if the people, even if people don't, even if people don't find other jobs, just the calculus for say a social safety net becomes very different if you are like in a place where you have like huge economic growth. So I think in this setting, like maybe I mean, for most people, like I said, I don't think employment is a goal by itself. It's a means to get what you want, like physical things. And if you can get this with working less, then that's also okay. Let me, I guess you had your hands up, and or is it like just directly to this point, or okay? So
Yeah, I guess just to build on that a little bit, like one of the things that scares me is the idea of power accumulation. Like I think this is a tool that will result in like a lot of accumulation of power in new places. And I think that like in terms of how a society can function and operate, a key to that is kind of like putting safeguards on that power and distributing that power in interesting ways. And I'm not sure that I've heard a coherent story yet about how we manage this accumulation of power and distribute it. And that's not to say that that story isn't out there, but I certainly think like that's kind of the question on my mind when I think about why I would be scared of AI is kind of like, is society going to be able to catch up to that and design the architectures it needs fast enough to adapt to that world? So I guess my question on that was kind of, is there a world in which you think like you're seeing so much disruption that frontier capabilities actually like are held back or not released because you're trying to like manage the disruption that's happening? Or do you think that frontier models as they come online will always just kind of like be pushed out as quickly as possible due to the incentive structures that are at play?
I think I'm curious what other people think. I think it remains to be seen like how society responds from a regulation or like societal acceptance perspective on frontier models. But maybe to Boaz's point earlier when he was talking about the power of labor, like I think one thing that's really interesting to think about is, labor has more power if the labor is more valuable. And on the one hand, I want to make sure people know that GDPval is like very limited. It only measures a well-specified subset of tasks. On the other hand, like the way that we came up with the tasks, right, is we went on the Bureau of Labor Statistics website and they like have a breakdown of for every job, what are the component tasks? Like for accounting, how much of the time is spent like looking up external material, putting together a budget, talking to a client. And so one might think that tracking progress on these actually is tracking progress in whether you're able to like differentially add value on tasks that make up the majority of the work that people are doing. And I think if the models get better at this sort of thing, it does seem like the power that the labor has uh, may be less unique.
Hello, thank you. So the first thing I want to say was playing a little bit of devil's advocate here is that I think no one has any value from a dysfunctional society, and I would like to hear whether you agree with or disagree with this, but I cannot see like the impact of AI becoming so high that like for example for companies to make money, people need to have money to spend, right? And things like that. It's like the everything is built around society, so that's why I'm like less scared on like huge societal impacts. But as someone who's like, for example, not very religious, there already isn't that many things that I can look at and say, this gives my life value. So and one thing that I feel like my friends and I feel strongly about is like the work that we do, giving us like our lives a lot of value. So if I'm just gonna be waking up every morning and it's gonna be like something I would have done in 6 months is gonna be done by an AI overnight, it's gonna it's great, like humanity is doing better, but also like it's a little sad because I cannot do it or anyone else can.
Yeah. I want to hear Kevin's thoughts. I also really enjoy my work and I would like to be able to do it. And I agree that a dysfunctional society is probably bad.
Yeah, I'm very I'm very sympathetic because I also care a lot about work. I feel like it's very important. I'm kind of conflicted because like I think there's maybe like some nuance. It's like I keep thinking back sometimes. Like there's this one anecdote about like someone like basically like when like the laundry machine is like first invented or something, and then like their response was like I feel like most people today would be like, oh, like having a laundry machine is like pretty useful or something. It's like not the craziest invention in my life or something. But to this person, like it was like they like broke down weeping because it was like their entire life, because like if you're taking care of a household, it's like a ton of work, and like it was like, oh, I have so much free time to like do what I actually want now. And I think this is obviously an extremely positively tilted example of like the ways in which like like I feel like not everyone wants to do the work that they're doing or something, but I do think it's probably true that like my guess is that it'll be a bit of a mix where like many people will feel disrupted and feel like a loss of purpose for a while of like not being able to do the work that they're previously doing. But I also think a lot of people will realize, hopefully, that like there's other stuff that they actually want to do, which is more important. And also in this transition period, also an interesting thing that I'm thinking about is like the distribution of work that people will do will change. But I think for a moderately long period of time, humans will still be like quite relevant in doing just like a smaller fraction of work that is much higher leveraged because everything else is being automated by models. And so like in some sense that is also helping. But I agree that like in the long term, this is still a problem.
Yeah, also for me at least, when I think of my career as like a theoretical computer scientist, and I think it's if you do kind of work like say, which theoretical computer science is very much like pure math. And I think sometimes people approach the motivation for doing the work is different. So some people may have thought about like they do pure math because they want to solve problems to prove that they are smarter than someone else, and they really kind of want to but I don't know. I personally like always did theoretical computer science also because I really was curious about the answer, and I wanted to find. I still want to know if the unique games conjecture is true or false, and if AI lets me get there and find this out, I think that's exciting. On the other hand, maybe it's not clear to me what will remain. Maybe even like the people that do math as a competition, that will remain just like chess is still like very thriving. They just turn the AI off and solve problems for entertainment. So it's hard to know. Maybe there would be no room for the curious. We will just be spectators, but the people that do it as competition will still have jobs.
I have a question for the group. Can you raise your hand if you read Deep Utopia? No one?
Utopia. I didn't read it.
There's one over here.
There's one over there. Yes.
One person?
Plus from, I think, yes. It's kind of like a follow-up to the super intelligence book that Bostrom wrote.
Yeah.
It was a follow-up to Superintelligence.
Yeah. I would highly encourage you guys read it because it kind of like takes the argument to the very fullest extent of like maybe there's some intermediate period where humans are better at some things, models are better at some things, and like humans are more leveraged by the models and can do the highest value work. But it starts to ask these questions of like, what do you do as the models get better and better? Like, for example, one idea is that people can spend more time in leisure, like shopping. But what if the model's better at shopping than you? Like, then would you want to go shopping if you could get better like things to wear if the model shop for you? Or like parenting, you know, and one thing is people can spend more time with their families and parent, but let's say the model is actually better at taking care of your child than you. Like, do you have a moral obligation to make sure the model can raise the child if the model might do a better job than you? Many parents might be like, wait, then it might be unethical for me to take care of my child. Anyway, the book takes up a lot further. It has a lot of cool thought experiments.
Yeah, these figures, like model being better at shopping, it kind of reminds me. There is this quote from Peter Pan, Peter and Wendy, where it describes the warriors, the Native Americans. They said, you know, they come attack in the night and they call to each other in a perfect imitation of the coyote. In fact, the imitation is so good that it's better than the coyotes themselves that are not very good at it. So maybe the models will be better humans than we are. Yes.
I have two main concerns, and the first one was sort of on the subject of power accumulation. I agree with that point. I'm a little worried about if these technologies do 10x the global workforce, then 9/10 of it is being controlled by like a small handful of companies. I think that's concerning. And then sort of on the parenting point as well, I'm worried about as AIs with the capabilities that they have right now continue to proliferate, I'm worried about the social impact that has on people substituting real life relationships with AI relationships, or children growing up learning that they should talk to AI about their problems instead of people. I think that's concerning too.
Tejal, Kevin, do you have thoughts?
I mean, I have no profound thoughts except that those are reasonable things to think about. I mean, one thing I think, at least at OpenAI, has talked about publicly a lot is like this issue of sycophancy or like the model being much more agreeable sometimes than like a human would be to you. And so then you like start to get more and more excited to keep talking to the model and then spend a lot of time with the model. And maybe like it reinforces beliefs that it shouldn't. And that is something that will be important to fight against so that, yeah, some of these examples of people just like becoming addicted to their friend are concerning to me as well.
Or like, yeah, I also have no profound thoughts. I don't know if you guys have also read like Neil Stevens' like The Diamond Age or something, but I feel like in this, like it describes a very like sort of dystopian like future society, which is like very like compartmentalized and like has a bunch of like weird social rules. And like there's this girl who grows up in this society, and like a lot of her learning throughout life is just like mediated by this like one book, which is like basically a smart, like what we now see is like just an AI book or something. but it like teaches her like lessons like science, philosophy, like how to think about like life and career. And it's like on one hand, it's like kind of good. On the other hand, it's like, is this like the best society that we could have created? Like probably not, I think. Like I think ideally you want people to be the people like guiding society and like letting it mature rather than like intermediating everything through like this AI, which like may not like, yeah, like it's something that's kind of just like a normative question. Like, do you actually want that or something? And I think that we should, yeah, I think we should think very deeply about this. Like, I don't know the actual thing, but we should think deeply about like, what do we want to happen? And like, understand that all these things are not like fully guaranteed outcomes, that you can also just like try to make things happen that you think are good.
Yeah, yeah, and this is another point to just remind you. I think I said it like multiple times. I do believe that people that are going to be situated, if people make a difference. Whether if you're going to be, whether it's in a company, in academia, in nonprofit, in government, and if you're working in the AI field or the AI safety field, like you could make a difference. And a lot of, I mean, some things might be fundamental. Maybe something might be kind of determined in terms of like raw capabilities. I think nothing will stop them. But a lot of the things of what we do with these capabilities might be path dependent, and the choices that people, companies, etc., governments make could lead to one way or the other. I mean, and one example that I like is my understanding. I'm not an historian. Maybe someone else is that like the printing press, although it was invented in both China and in Europe. In China earlier, it had like very different impact in terms of like whether it helped government govern better or and maintain control, or actually introduce things like the reformist and upended power. And it was the same technology. It was just basically the way that it was used.
I was just wondering whether you think it's possible that this idea of AGI, like artificial general intelligence and artificial like superintelligence, is something that is inevitable, or whether you see a world where people perhaps agree to not pursue it and maybe pursue like artificial specialized intelligences, as in we create like machines that only do one task really well, and then just use those to augment humans as much as possible rather than trying to go for like this human replacement idea.
I'm curious what other folks think. To me, it seems pretty plausible that we are so far along that like at least our general understanding of like a model that can automate most economically valuable work seems like it will happen in a medium-term future. But yeah, I'm curious what Boaz, Kevin, and others think.
Yeah, I mean, I actually think it is inevitable unless unless there is kind of some really huge surprise of like a fundamental technical roadblock that we don't understand. And part of it is because this kind of what we have seen with the bitter lesson. I mean, a priori, you wouldn't expect that like the best models today that we have for coding have been trained on all sorts of things, like on Reddit, on internet chats, on whatever, I don't know, whatever they was trained on, but you wouldn't expect that like the best coding specific models are actually being trained on tons and tons of data that has nothing to do with coding. And I think just generally, it will happen that even if you wanted to be very, very good at a special task, the way to do it would be to pour a lot of compute and into becoming generally better. So I think it would be very hard to kind of restrict and have like an AI that is super great on very, very restricted things and not good at other things. I don't know if Kevin, you.
Yeah. Or like, I think I disagree. I also think like, I mean, I think timeline is a question. Like, I think people could choose to like delay if that was a desire. Like, I think it's actually like kind of plausible, but I think that like, it seems to me like the actual avoiding the entire creation seems very hard, because I feel like at every micro step, you're like the decision of like build a narrow system or like just hand everything over to the general system. I feel like just almost always just better to do the general system. So you basically have to say no every time to like a series of like a million decisions or something like this, which I think is quite tough to do. I don't know, given that our coordination is not that good in society, I feel like.
I just really quickly wanted to comment on that question and also to what you were saying earlier, Kevin, about like posing the question, is this the ideal society and do we really want this? My worry is that like we no longer have any agency in that matter and kind of, yeah, it's inevitable. It's happening. And then my second thing is, sorry to detract from the philosophy, but I just had a question on GDPval.
That's great.
Which is, so right now, right, you were saying that we have to feed in like 13 pages of like super specific instructions. And so it's like, it's only relevant for well-specified tasks. I'm curious, like what we expect or what we want the future AI to be like. Do we want just like a general model, like to prompt a general model without any context and have it be able to complete a task as well as a human? Or do we want to, in the same way that we like train a human in a specific role, like give AI the same training and then eventually expect it to be able to complete any such task, if that makes sense?
I can handle the GDPval question first. So, so some of the tasks have a ton of 13 pages of specification. Some of them are not quite that long, but we have an experiment in the paper where we just give the model a bit less context and see how it does. And it does degrade performance, but not that much. But as you can imagine, the more specification you give, the like easier it is for the model. But some things that, seem like they will be happening inevitably are, the model learning how to ask for more context. Like, for example, deep research already does this, where if you ask it a question that's going to take a long time, to not waste time, it'll like ask you some follow-up so it understands in a more specified way what you're asking for. And I do think a goal of these developers is to have models that can understand context well and not overburden the user and like try to help you proactively with your needs. And so I do think in terms of is the goal of some of this training stuff to have a model that can sort of operate without overly specified context. That seems very much like a goal because it would make for a more useful model. What the implications of that are that it'll probably be more useful, but then there's this broader societal stuff that we've been talking about.
Yeah, I think also like in practically speaking, if you were to deploy, say, a model to do these kind of tasks in any kind of workplace, you'll probably have like a lot of examples of kind of similarish tasks and generally like internal documentation from the company that you could give to the model, so it wouldn't need all of this context for any individual task. Yes.
I also had a question about the paper and specifically how anthropic models were better. And in the paper, it kind of says that the anthropic models were better at formatting and presenting the final product that the experts judged. So I'm wondering if you saw that there's that last mile that the model has to get to get a better score. So for example, GPT-5 might be better at actually completing the task, but then the presentation and the deliverable might be worse. So then that gets scored down. So I'm wondering if you saw any difference in terms of like the actual content and how much the model was able to perform at that specific task versus, maybe some biases that, the judges might had when it comes to how they expect the deliverables to look.
Yeah, I think we saw exactly that. Like that's part of why the OpenAI models perform the best on the pure text tasks that are just reasoning. There's no formatting or file manipulation involved. But maybe to be even stronger, it's like some of the OpenAI outputs were like horrendously bad. Like I don't even think the experts were biased when they were like, I would not pick this. It'd be like a completely unusable PowerPoint deck that you would like never, it would like take more work to fix than to just do it yourself. And I do think one thing that we've been thinking about just for some, and Kevin will talk about research and like pushing the frontier of science in a bit, but for some of the like everyday work that people do in the economy, it doesn't necessarily require like the most frontier thinking like of all time. It does require like a good presentation, being understandable, and this is just something that our models had historically not been super optimized for, which is what you saw in the results. But I do think it is fair for experts to want that in an output, because a lot of the job of a consultant or a banker is like to make a clean deck, a clean model that's understandable. And but I do think if we try to make the models better at this, just like you saw with the prompting exercise, you can make them better at this stuff much quicker, because it doesn't require some frontier leap in intelligence. It's just like make sure to present the work well.
Sort of a meta question, but I'm curious for the two of you, after spending a lot of time looking at these like fully specified prompts for realistic work tasks, and also thinking about where it's successful and where it's not, if there's any ways where this research has changed like how you prompt AI tools, or like what you choose to use AI for at work and for your own like work tasks.
Does it change how I prompt? I mean, we have that prompt that makes the model better at like files, which I think is in the paper. So, you know, if you want to make a file, use that. But also, I don't really use GPT-5 to make files for me. Like, I just think my job was not on the list of occupations for GDPval, so it's not super relevant to me. I think what's more interesting is to track whether our models natively become better at these tasks, as maybe an accountant or a lawyer or banker would use them. I more like the improvements in codex. I'm curious, Kevin, what do you think?
Yeah, I think yeah, I agree there's no direct transfer. I think that there is some claim that's like similar to GDPval. I think like, so I usually use models for coding, but I think it's like, it often looks super dumb. Like the first 3 commands the model writes, I'm like, this is like super dumb or something, because like it just doesn't understand the internal context. But it's like, I think there's just like really high returns from just like, I mean, I think everyone knows this, but like you can just like give the model a list of like, these are like terrible ways to do the problem, and these are like good ways to do the problem, and these are the general things you should try to consider, and like this kind of thing. And just like helping the model out with the like, sort of last mile stuff where it doesn't understand, it just like is like quite good or something. Like this, it actually is like, maybe the claim is something like it is like very worth to just like put in like substantially more effort than you thought would be reasonable to use AI tools or something, because returns later can be very high.
Yeah, actually, like in the prompting part, I'm also curious about one thing. I don't know if you tried. I just saw like on the slides that a lot of the prompts started with something like, you are a consultant, you are an expert. Do these matter, or we could just drop the sentence and it would be the same?
We actually did test that. It doesn't matter that much. What matters is like some of the specification basically tells you how to do the task. Like it'll be like, go into this file, do this. And like it just saves you a bunch of time and like trying to figure out what the task is. So that's the part of the prompt that like saves the model a bunch of time and makes it easier, versus saying you're a customer service agent when like the task is clearly customer service didn't really matter.
Hi. First I want to thank you for releasing the public split of the dataset, and also the automated grader for all of us researchers to use. I think it really helps with benchmark transparency. But at the same time, I submitted like 2 things like 5 weeks ago. I received one like 2 weeks later, and one is just lost. Like I haven't heard back after 5 weeks. So I was wondering if you know anything about like actually making it useful for researchers to use GDP. Let me try to phrase this better. Yeah, like yeah, I guess you get the idea. Yeah. But like, are there any plans to like open source like the automated grader, like for example, open source a model, or like open source the grading prompt for it?
Oh no, I'm so sorry this happened to you. Please email me. First of all, please email me, tejal@openai.com, and I will see what happened to your lost submission. So first of all, I'm very sorry. Candidly, the automated grader is not that great, so we're actually thinking about potentially just making it easier for people to grade themselves by open sourcing more of the eval. But I don't want to make any promises to you here, but know that you're not the only person who's complained, and I think our automated grader service has not been super reliable right now, so we're going to try to make it better. But I'm sorry you had a bad experience. But yeah, we want people to be able to use this.
Thank you.
But please email me, otherwise I won't know about your situation.
Tejal at OpenAI. Just say CS2881 in the subject. Yes, you can see me.
Yeah, thank you so much for your talk. Just to build upon your point about the fact that the models don't have really a great understanding of aesthetics, specifically for the PowerPoint presentation slide deck sort of creation, that it it's really bad at like formatting. So I was just wondering, I was looking through the GDPval, one of the tasks being the manufacturing engineering task, where you're being prompted to create some sort of like CAD model. So I was wondering how the models actually perform there, because I feel like it's sort of like requires some sort of spatial understanding to do some sort of like 3D modeling, similar to, I guess, like creating PowerPoint decks in a way.
Yeah, the models, or like, I'll talk about like the OpenAI models. They're generally not as good, right? Or like GPT-5 is not as good right now at stuff that involves a lot of file manipulation, like CAD stuff, really multimodal, really long horizon, really large files. Um, One thing I've learned in life though is once you start to measure something, it becomes very easy for people to uh, start paying attention to those features. So one might imagine that like this could lead to improvements because, you know, I think like, for example, the multimodal team might not love being like, oh, Claude is like doing better than us.
So maybe this is a good point to take, like, we can take a 10-minute break and then we'll do the student experiment and then we'll go to Kevin's part. And we'll thank you at the end, but let's thank them also now.
Okay. Yeah, I'll have a somewhat briefer thing, but it'll just be like, I think we talked a lot about like, yeah, evals and understanding models on frontier capabilities. And I wanted to go into sort of like micro detail about like, hey, we have all these coding agents, like what's going on? Are they like actually automating research? Like, what do we expect to happen in the next few months? Like, just based on like the kind of like knowledge was like public understood about this area. Because I think it is going to be a really important aspect. People talk about like recursive self-improvement, that kind of thing. I do actually think there'll be one of the most significant impacts of AI in the next like few years or decade probably. And so I think it's very important for people to understand what's going on. Yeah, so like this is kind of like the classic meme graph, which everyone shows all the time, which is like, wow, models are getting really good. You can see the most recent 5.1 Codex Max model, great shout out, is doing quite well in this benchmark. We can also see, and notably, these are both software engineering specific benchmarks. So like we can see that like on software engineering in particular, models are getting quite good. We can also see Terminal Bench, which is just a kind of grab bag of a bunch of random tasks you do on like a Unix command line. Models are also just like steadily improving at this. And I'm sure you guys have all used like Codex or Claude Code and realized that like models can just like do a lot for you. And so I think the question that I want to ask, oh, and another thing is like, we can actually also measure specifically progress on things relevant for AI research. So this is a screenshot from Paperbench, which is our paper on like reproducing like ICML papers, and graded based on like a very detailed rubric of like, you know, did you reproduce all the key results? You got all these like side findings and stuff like that. And you can see that at the time, 01, it's like not that good in the sense that like it's very quick to like get a good score, but then like it gets outperformed by the human after like 2 days of like subjective work time on these like 4 papers in this subset. But we can start to see that like models are kind of being promising. And the question I want to ask is like, why are models just like not automating research today? So I think that's the fundamental question which we all want to ask. I would kind of claim that there are a few reasons for this. One is very basic, which is just like AI research, I feel like is often just bottlenecked on like compute and like waiting for an experiment rather than the actual coding. I think there's some ways around this, which we could talk about, but like primarily today, like it just like you often just have more ideas than like you have like time to actually like run or something. And like it's just very interesting to like see that this is kind of a problem. Also, ML code is like kind of slow. Like my kind of bad mental model here is that ML research is just like software engineering, but like much slower in the sense that like you just have a bug and then like you're just like, okay, I don't know, it's gonna take like a day or something to like run this experiment and see if it actually fixes. Whereas like in software engineering, you like press a button to rebuild and in like 2 minutes, you're like, oh, I fixed the problem. And so that makes it very hard. Also, one thing that I would claim is that verification is very hard. One thing is that like I talked to a few people. There are a lot of like very subtle bugs which come up. Here are 2 examples. One is like this Anthropic bug where it's like they're implementing some TPU kernel and then they're like, oh, there was a bug, so we fixed it. But then like by fixing the bug, we introduced like some other bug, which is actually like a compiler bug that like affects like certain batch sizes and model configurations from their blog post. And it's just like, it's kind of just like terrible. Like it's like 100 lines of code or something. And like, turns out there's so much latent complexity in here because like just understanding like the massive amount of parallelism for kernels in particular can be very challenging. And like also the complex interactions with like the compiler and other parts of the stack. I also want to highlight some other one from Codex. There's actually some random tweet that like Thibaut tweeted once, but like he linked this Google Doc. And in this doc, they're trying to describing like, they're trying to debug like, is Codex actually getting worse or not? And like, they're like, we ran some evals against different hardware types in the fleet at OpenAI. And we found problems with some of the hardware based on a predictive like regression on like a bunch of user metrics. And I was like, what the heck? Like, why do we have to do this to like find like the subtle problem? Some of the reasons why I think are that like, it's very hard to actually tell because the model still works in a degraded state. It just doesn't work quite as good in a way that's very hard to tell.
Yeah, in my first lecture, I don't know if you remember it, I said like part of the reason why I think AI is so challenging is that the space of things, like you can have a problem with the model and the solution might be either to fix like a numeric bug in the kernel or to talk to it in a more stern voice. Because you don't know, it could be anything and everything in between. Like,
yeah. And then we have the classic Greg tweet, which is sometimes there's no way to debug besides staring at the code. And I think the claim that I would try to make here is something like, there are a lot of domains in software engineering that are very easy to verify. Like if you're writing a website, you can just kind of look at it and you're like, well, it looks right or something. For ML stuff, often it could like mostly work, but then like if there's a bug, it requires such deep analysis that you have to basically perfectly understand the code that's happening. And so it makes it a lot harder, like in this sort of claim that GDPval makes, where like you could run the model and then verify, and then if not, do it again. The problem here is that verification is hell expensive, it's very slow, and extremely hard for a human. And so that makes it a bit challenging, like if we consider like, why is it not happening literally today? Another thing I'd call out is like, this might also be like a specific thing to some workflows, but like, you're often comparing like runs done within like months of each other, and like random ablation that you did like 2 years ago, you're like, oh, I don't know, like, does it still work today? And so you often want to be able to go back to that level of the code, which is basically saying I want to maintain every version of a software repository in perpetuity and make it always have the same results, which is very hard. That's very hard for humans. And it's, I think, especially hard if you don't understand all the code that's going into the system. Yeah, so that's one thing. Anecdotally, what I feel like I've noticed is like, a lot of people just use Codex and Cursor Agent. There's like very productive people at the company who just like barely touch it. Like one of the people on our team for like a long time, he just like used Vim and he just like Vim'd it out. Like he would like SSH in, use Vim, just like type a thing and just like work the first time. And like, in fact, this just like was a pretty productive strategy because verification is very hard. And so it just seems like results and sort of today's AI automation don't directly seem correlated yet. Another thing is that like, I don't know, the infrastructure to run large chain runs is very complicated. And so this makes automation trickier, and it also results in longer feedback loops, which are harder for models to iterate on. Because another model you could have of the world is that like, let's say Codex or Claude could figure it out if it got like 20 tries of the problem. A human could do it if it had 5 tries. This is fine if every try takes like 10 seconds. It's very annoying if every try takes like 2 days or something. And so, yeah, by contrast, for example, like if you're doing front-end, back-end, app dev, this to me seems extremely accelerated because you're just like basically banging out a ton of features. You can just check that they work very quickly, and you can just like make a ton of progress in this area. Yeah. And I also want to talk about the way in which it's very unevenly distributed, like what is actually sped up by models and what is not. I think, so on the right, there's 2 examples of like what I thought were very interesting papers released. One is like this sort of like transluces, like, it's sort of like this transluce like investigator agent system where like they're using models to try to like find sources of bad behavior. And then like another is like find sources of bad behavior in other language models. And then another is like Anthropic's pretty like similar in concept paper, which is like you basically have this agent which can use a bunch of tools to audit another model, and then you can find a bunch of issues. And these are kind of very interesting because they're kind of things that like people do, but like not to the same level of quality or rigor that actually a model is able to do in this case. And in some sense, one could probably envision that like models could become like 10x better auditors than humans based on these results. And I think, but that is not true of most domains. I think I'm going to claim the key properties of why this is actually possible are like, A, it's very hard to do, but fast to verify. Like if you see an example of misalignment, you can just look at it and you're like, wow, that was in fact bad. Failures are also tolerable. Like basically like, I think domains in which it works well are like things where either I'm writing throwaway code or nothing is depending on me. So for example, if I'm writing complicated infra code in the middle, that may be a very bad place to use models because if I screwed it up, it might take like months to figure it out. And also in this case, it's kind of fuzzy correctness. Like I don't have to get the problem fully correct, to understand that this misalignment was like useful to me. Like I don't have to get every example of misalignment. Other things like it doesn't need very deep context from models are bad at, from like GDPval and stuff. Also benefits from just kind of like another model I have is just like models are really good at things which just like require a lot of effort, but not a lot of like raw brain power. Like if you just like bang your head at the problem for like years and you could figure it out, like then I think that like models would be like very useful in this domain. Yes. Another one I think is like codex review, which I think is like kind of memey. It's like, wait, literally codex like review is like, there are many cases where I'm just like, wow, like this just like is also right here. I think here in particular, it's useful because like it's just purely additive. Like verification is pretty easy, not always actually that easy, but it's very additive in the sense that like the time cost is very low for me to check it over and sometimes catches like interesting things. Yeah, so those are some examples where it could be useful. Yeah, I'm just gonna go and make some random predictions because I think that like, I always think that it's very useful to be very specific about like how we think the future is gonna play out. So you can try to evaluate like if you're doing it correctly or not. A lot of this stuff also is definitely stolen from random blogs that I've read. Like Ryan Greenblatt has like some good articles from Edward Research on this. One claim is I'm gonna guess the proportion of vibe coded research code, which is basically anything which isn't core code, but like very either easy to do or just like throw away, like maybe do streamlets, like data processing, plotting, sweeps. This is going to go up a lot. Probably like in terms of raw volume, this will be like the majority of code in the future, and also models will be writing all of it. But I'm going to guess that this is not in any sense 80% of the important work done, in the sense that like these domains are going to be sped up, but like everything else will still be very bottlenecked because of the sort of verification problems. And the reliability and trust basically might be bigger than we think to achieve full automation based on the above numbers. Like, for example, like people are saying like, oh, like models are gonna be running 8% of the code. I think that this does not mean that like, in some sense that this is like materially going to be like a, 5x speed up or something for the entire line of work. I think another thing which is kind of interesting and not really AI specific is that workflow adjustments are very slow. And so like one interesting part is like, we kind of have a world today, it's my model, a world built for like both 2-second agents, which is just like deterministic computer algorithms, like, CRUD apps and REST and stuff like that. And we have 2-year agents for these human engineers who will work at like some FANG company and then like leave after 2 years. And like both of these are pretty effective today. There's actually not much in the middle where it's like 2 days. Like it's very hard to get somebody to use it for 2 days. And that's kind of the situation we're in now, where like models can work on sort of like a few hours or day-long time horizon. And it's actually kind of hard because you have to change a lot of workflows. You have to like, for example, you write like those like Claude MD or Agents MD files that explain the basics of your code base so it can be useful. That's like the most basic thing. And then you can imagine you have to build these specialized systems like SaaS apps to like get the most use out of like 2-day agent systems. And so I think there are 2 claims here. One is either if that world continues, you might expect those workflow adjustments to be pretty slow and require a lot of manual work. The other answer is maybe you should just make the model a longer time horizon, and then maybe it'll be more incentive compatible with the system we already have. Like you get to a 2-year agent, that might be a major transforming factor in the utility of the system, just because our economy is already built for 2-year agents.
If the economy becomes hotter, then the humans will become 6 months agents, so you have less to catch up.
Yes, that is also true. Yeah. Yeah. Okay, the last thing, or I think like some of the last things I'll say is like, another thing which I just want to kind of highlight as a comment or like an interesting thought is like, I think people are pretty familiar that models in terms of raw capabilities scale, like they scale pretty predictably. There are like many examples like qualitatively and quantitatively on this. For example, this is another meter time horizon graph, but you just like put the y-axis as log and then just like a straight line. You're like, wow, this is like pretty interesting that it's like a straight line over like a linear time axis. But I think that one thing which I would say is like, it's not always true that like just because you know the system scales predictably in terms of one metric per capability, that the impact is going to be predictable as well. Like I think that like a very toy model is like if you model a real world task, it's a combination of a bunch of other subtasks, all of which need to be done to do the problem. And we kind of see this GDPval where like you have to, like a real world task is like, I did this research, then I made a PowerPoint, then I like formatted the thing and like didn't include any special characters. And it is like one of these being missing can bottleneck everything. And like, if that is true, you can imagine a world where like the total task success rate doesn't really look very predictable over time because like this just happens to like fix like one problem and suddenly it goes like to 100 or something. That's a very naive case. It's just like much simpler than the real world. But I think we kind of see it a little bit in the sense that like in the real world, models have been getting better continuously, basically. But the sort of step function improvements or like moments when people are like, wow, that's really useful, have been very almost not quite discrete, but like very like there's like a clear step change. There's like ChatGPT comes out, but like these like long horizon coding agents come out, and suddenly there's like 10 of these going on at the same time. And the question that I would ask is like, what is the next one? And like, what do you guys think it will be? And also like, what's the one after that? And like, yeah, in what way does that change your picture of how like economic impacts play out or something? Yeah, that's like basically it on AI stuff. I will also talk about AI for science, which I'm definitely not an expert on, but I will just make a few layperson's observations on. I think definitely most people in this room probably have better observations than me, but just some other thoughts for discussion. Yeah, there have been a lot of like kind of like meme comments on Twitter and stuff about like, wow, AI is like incredible for like science and do this interesting mathematical thing. I think a lot of these are actually true. I think it like maybe also benefits to try to be like, but why, or like what in particular is the model being good at right now, and what is it bad at being good at right now? And I guess I would argue the skills the models seem very good at is sort of like literature review, turning over every rock, and also doing like some like mildly, actually quite complicated math, but like not some insane like, you know, week-long like project where I try to prove a bunch of stuff, but just like, oh, you gave me a pretty well-defined problem, I can just like figure it out for you or something. And so also, yeah, I feel like you would probably have comments on this as well. So feel free to jump in at any time.
I mean, I have not yet used it for original research, but I would say that, yeah, like definitely for any kind of literature review, it's worthwhile. Also, I think if these days, like what I find, like I'm now like working on a paper, and what I found useful is, and I'm sure you could do the same with Cloud Code. I use Codex, but I took the Git from Overleaf. And then, so sometimes I use Codex for LaTeX things. So complicated LaTeX things, I just say, okay, here's this thing, just do it. But sometimes I also ask Codex to go and search up references and then mark up, like go over the entire paper and leave some notes where it thinks there are things like that are like not clear. And that was useful. It didn't prove to any, like this was an empirical paper. It didn't do anything original, but it was very useful. In CLI, I think it's really nice. Like you just let it churn on the LaTeX and it goes and yeah. So, but this is more like the bibliography, etc., not the original stuff.
Yeah, yeah. I think like the one comment I like from this is like Scott Aronson, I think, in his blog, where he just has some like, oh, like it like derived this like interesting fact for me. It's just like it's kind of like a system that can like merely fill in the insights that should have been obvious to you, or like, you know, all these things like it's just like you think are like kind of dumb, but like actually like are like a large part of the actual work or something. And I feel like that stuff is like very interesting. Or yeah, I think that stuff's pretty cool.
Yeah, I mean, I think there is. I mean, it can be a little bit of a double-edged sword, but the following, like there is the famous joke, I don't know if people know it, that a mathematician says, a mathematician gives a talk in class, and it says, okay, this thing follows the formula 17 follows from formula 16 in a trivial way. And then a student asks, why is it trivial? And the mathematician stares at it and in silence for like 10 minutes and then says, it's trivial. And this is indeed true. Like sometimes like there are some things that are kind of trivial but take you a lot of time because you're not really thinking of them in the right way. And now the model can do these things for you. The double-edged sword is that sometimes you gain something from reworking trivial things. Yeah, and I kind of like, I don't know if you remember, like in the first or second lecture, I reworked for myself really because I forgot, like, why does the derivative of e to the x is e to the x? and I even had put you through that. Put a slide on it. And I think these things, you gain something from redoing these trivial things, and you might lose it if like the model does. But eventually, you probably learn to work with the model, and it's ultimately better, like we use calculators.
Yeah. One thing I wanted to add that this makes me think of is, do you remember like in the old days or like a few years ago, we would be like annoyed if someone asked us something they could just Google. We'd be like, you could have just Googled that. A shift I've noticed is that now people get annoyed when people ask for things they could have just codex. Like it's like, why are you asking me to do this? Like you could have just codex this yourself.
Yes.
And I think our definition of what is trivial will continue to shift.
Yeah, I think it also kind of it changes if you are beginning in the work or like like when you're already advanced, you gain less from the education and it's better to just use the tool to get it quickly. Like actually, the thing that I say to any new employee that I onboard, like any one of my kind of people new to my team, I say in the beginning, even if you could have used Codex, I would rather you ask me. I'd rather you ask me questions because then you learn from like talking. Eventually, like you just use Codex for these things, but or like use the tool like ChatGPT with internal knowledge to ask this question. But in the beginning, I'd rather you ask me questions, even though you could have Googled it or chatted it. But with time, you just move to that.
I agree. Yeah. Yeah. The last two things I'll say are yeah, I think like yeah, I want to like kind of like combine like all the stuff we had before, which is like, yeah, this is kind of like where we are today. I feel like where models are good at like the review, they're kind of doing the things which are trivial, etc. But this is kind of like also current models. And I think I want to ask like, yeah, what happens when you just like wait a while, you use these predictable trends and you just like take some time. You're like, oh, what about like when I have a 2-day, 2-week, 2-month model? At what point does like stacking like 15 trivial things actually become somewhat interesting? And like to what extent like do people's work mostly rely in like the ton of like perseverance that it takes to like go through a problem, understand it, and at every point do the thing that's kind of reasonable, but then put it all together in an interesting way afterward or something. And the final point I would also make, which is somewhat separate, is like if we think about things that aren't like math or like physics, I think that there is a lot of good science which is bottlenecked by basic, not basic even, but just like sort of like software engineering problems that we kind of also know how to solve, but are also just like, maybe it's like the right people aren't there at the right place. Or for example, like one example is like, I was talking to a bunch of bio researchers like last weekend or something, and like there's some major thing which is just like, wait, if we just had a standard data analysis pipeline which took in a bunch of different data sources of different types, unified it together, like this would save like days every time I did this like new analysis. Because otherwise I have to look in Excel, I have to be like, okay, like do the little bases like match up and this kind of thing. I have to write my Python script or R script to do this. And it's like, how many of these problems, many of these problems might be solvable if the lab hired a software engineer, for example. But that takes time, that takes money, effort, like coordination. If we could just ask Cloud Code or Codex to do the same, this is not a very complicated problem by the sort of like frontier standards of like systems being done in the world, but it does require skill and effort. Like how much time could that save alone? Yeah, yeah. Anyway, that's basically all of the thoughts. I mean, we have some other stuff. I don't know if we want to discuss this or go to the safety stuff as well.
Yeah, maybe we can do the safety and then have like a question at the end.
Yeah, done.
The safety's pretty short, but Kevin, you should refresh. It's literally 2 slides.
Okay.
And then we can
Okay.
discuss.
So huge. Okay.
Okay. We just wanted to make sure we touched on 2 other topics. So if you go to the next slide, one thing that we've been thinking about is as these models get more and more capable, there's going to be a larger surface area of things that we need to measure before we launch the model because we really want to understand what they can do. And I would encourage you guys to literally like, go look up right now, like the GPT-5 system card or insert system card of any model you're interested in from OpenAI or other providers. And what these cards do is it's basically like, 50 plus page document where you try to evaluate every possible thing that you can about the models. Like, how are they doing on hallucinations? How are they doing on health risks? How are they doing on telling you illegal content? How are they doing on frontier risks? Like, risk of helping make a bioweapon or helping conduct a cyber attack. And the goals of these are to, proactively surface and mitigate risk before a model is launched and then to continue updating after a model is launched. And I think there's a bunch of interesting safety questions that come into play now on this second slide as the capabilities of our models get better. So one of them is just how do you make sure your maximally eliciting capabilities are the best of what the model can do? So, you'll evaluate a model on whether it can, do sort of like a cyber related task, but then you might realize that as you put in more test time compute or scaffold it more or prompt it more, it's able to do more. And so there's a lot of science and research, and a lot of it's still open into how do you maximally make sure you're measuring these things before they're actually deployed. There's also this increasing problem that's coming up that you might have heard about situational awareness, where models realize could realize that they're being tested before actually being deployed. And so the results that we see in testing might not actually be representative of what happens when you deploy them into the real world. And then a third thing that we want to talk about is, you know, as these tasks that we want to test for become increasingly advanced, it becomes really hard to do them in like a time boxed setting before a launch. Like, for example, if you're worried about some really long horizon, like bio attack being planned, you kind of just like can only measure that if people are actually using the model in a wet lab in the real world over a long period of time. And it's just kind of hard to measure before a launch. Like, you just won't be able to get enough people involved and have the long enough time horizon you need. And so I think as the models get more capable, there's going to be these increasing gaps between what they could do on their tail ends and what's even feasible to measure before you put them out into the world. And so there's this like work that needs to be done on like, okay, do we have good scaling laws of if we can't run the model for a month or a year of work, can we like predict what it could do at that time horizon from shorter periods of time? Like, evaluate it for a day and try to see if it's so much smarter that the week-long impact or the month-long impact might be really large. But I really encourage folks here to just like actually look up a system card and like read it, because like that'll be like the best way for you to like see some of the things that people are testing. And I would like to emphasize that there's so much open research here that we don't have answers to on, you know, these models. As they get more capable, they can be used for beneficial use, but they could also be used for a lot of dangerous impacts. And measuring that is going to be only increasingly hard, and more research is needed. So I think those are my scare everyone implications.
Hey. So I thought maybe we could yeah, stop recording and just kind of have did I stop recording?